Welcome to the topic of file organizations. In this presentation, we will explore the efficient methods for storing and retrieving data in computer systems. We will discuss three primary types of file organization techniques. These are sequential file organization, index file organization, and hashed file organization. Each of these methods provides different trade-offs in terms of storage space, retrieval time, and ease of implementation. Let's begin. Let's delve into sequential file organization. In this method, records are stored physically in a specified order, based on a key field value. This means that the records are sorted by a primary key. It's an efficient approach for batch processing, where large volumes of data need to be processed in a single run. Sequential file organization allows for fast sequential access, as records are stored one after the other. However, it can be slow for random access because you may need to traverse the file from the beginning to find a specific record. Due to insertions and deletions, this type of file organization requires periodic reorganization to maintain its efficiency. As you can see in the diagram, the records are ordered by their identification number. Here, we'll look at the common operations performed on sequentially organized files, along with code snippets to demonstrate these operations. First, let's examine the search operation. Finding a record in a sequential file often requires scanning from the beginning until the target record is found. This is illustrated in the sequential search function. It starts at the beginning of the file and reads each record until it finds a record with a matching key or determines that the record does not exist. Next, consider the insert operation. Inserting a new record into a sequential file requires finding the correct position to maintain the sorted order and shifting subsequent records to make space for the new entry. This is demonstrated in the insert record function. It locates the position where the new record belongs, shifts the existing records to create space, and then writes the new record into the file. Now let's explore index file organization. This method uses an index structure to locate records in the data file, without requiring a sequential search. This is different from the sequential file organization where you have to traverse from the beginning to find a particular record. An index of key pointer pairs is maintained. This enables faster random access to records, as you can quickly locate a record using its key. It also supports multiple indexes on different fields, allowing for flexible searching and sorting options. Index file organization significantly reduces search time, especially for large files. However, it requires additional storage space for indexes, and the index must be updated whenever there are file changes to maintain accuracy. On the right, you can see a sample index table along with the data file. In this slide, we'll explore different types of indexes. First, we have the primary index. A primary index is created on the primary key field of a data file that is already ordered by that field. The data file is physically ordered by the primary key, and there's one index entry per block of records. This results in a sparse index, which means the index size is smaller. Primary indexes offer fast retrieval for range queries because the records are physically sorted by the indexed field. Then there's the secondary index. A secondary index is created on a field that is not the primary key, or on which the file is not ordered. The data file order is independent of the index. A secondary index has one index entry per unique field value, resulting in a dense index, which means the index size is larger. Secondary indexes support multiple access paths to the data, making it versatile for various query types. Let's turn our attention to hashed file organization. This method uses a hash function to determine the location of records, enabling direct access without searching through an index. It provides the fastest access for exact match queries. A hash function maps keys to bucket addresses, where each bucket can hold one or more records. There's no need for index maintenance, simplifying the management of the file. This approach offers constant access time regardless of the file size. However, it is not efficient for range queries or sequential processing, because the records are not stored in any particular order. It can also suffer from collisions, which occurs when different keys hash to the same bucket. This requires overflow handling techniques to manage the additional records. On this slide, let's understand hash collision handling. Since it is possible for different keys to hash the same bucket, we will discuss two common methods for resolving this issue. The first method is called open addressing. When a collision occurs, the algorithm searches for the next available slot in the hash table, according to a probing sequence. Examples of probing techniques include linear probing, quadratic probing, and double hashing. The second method is separate chaining. In this approach, each bucket contains a linked list of all records that hash to that bucket. When a collision occurs, a new record is simply added to the linked list of the corresponding bucket. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.